Hello, in this lecture I will try to answer the question, is the universe infinite? The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 14.8 is because it has been 13.8 billion years since the Big Bang, so any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure that it is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privilege or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale, the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have a positive curvature, which is like the two dimensional curvature of the surface of a sphere. Like that sphere. That is to say, the universe closes inward and it is finite, like so the universe has the shape of a sphere. That is one possibility. The other possibility is that zero curvature. The universe has zero curvature, which is like a flat plane, like a flat plane with zero curvature. That is to say, with no curvature at all. So the universe is then the universe is not closed but infinite, like the flat plane that is not closed, of course. Or the third possibility is negative curvature, which is like the curvature of the structure of a saddle, like the saddle here. Then the universe is not closed at all and it is infinite. You can say that the shape of the universe is like the saddle, that it is not closed, and that is to say that it is infinite. If the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, then the universe will be finite, just as the surface of a sphere is finite. So the universe is in the shape of a sphere. And of course finite. On the other hand, if the curvature of the universe is a constant of 0, then it is like in the shape of a flat plane, and it is not closed. Or other possibility is the universe has a constant negative curvature. That is to say, the universe opens outwards and never closes, like so the universe is in a shape of a saddle, and the universe is infinite. And the universe would be truly infinite. Do we have any measurement of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all well-measured cosmological information, as a parameter of total omega, which is related to the curvature. So the parameter of omega is a number that measures how much the universe has the curvature. So if total omega is greater than 1, then the universe is positively curved. So if total omega is greater than 1, like here, then the universe is positively curved. And it is like the sphere. If total omega equals to exactly 1, the universe is flat. If total omega equals exactly to 1, then the universe is a plane flat. And if the value of total omega is less than 1, the universe is negatively curved. When total omega is less than 1, then the universe is like a saddle and it is negatively curved. The best measured value is total omega equals to 1 minus 0.12. Okay, total omega equals to 1. Total omega equals to 1 plus minus 0.12. That is to say, total omega, so if total omega equals to 1 plus 0.12, that is 1.12, and actually total omega is greater than 1, then the curvature of the universe is positive. So if total omega is greater than 1, then the curvature of the universe is positive, and the universe is in a shape of a sphere, and the universe is closed, like the sphere in the picture. And if total omega equals to 1 minus 0.12, that is 0.88, that is less than 1, then the curvature of the universe is negative. Okay? Then the universe is in a shape of saddle and the universe is infinite. Okay, so if total omega is less than 1, then the universe is in a shape of a saddle and it is infinite. I actually repeat on these things in order to clarify it as much as possible. So the universe could be infinite or closed. It could be everything from positive to 0 to negative curvature. So there is no definitive answer at this point, but the universe is consistent with having 0 curvature. Because the total omega is close to 1. It is 1 plus minus 0.12, so it is close to 1. So we really don't know if the universe is infinite at this point, but since the value is so close to flat, even if the universe is positively curved and finite, it would definitely be much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. At the moment, we don't even know if it is finite or infinite. But there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.